Okay, today we're going to go back to school. I mean, way back. We're not actually here to learn about computers, but something maybe more interesting, how we first learn about them. You see, I stumbled upon this fascinating document. It's a cyber Olympiad test, but it's for 6-year-olds. And honestly, it's a total masterclass in how to explain really complex tech with these simple, just brilliant ideas.
So let me ask you, how do you think you'd do? I mean, yeah, you probably know what a CPU is, right? But the real magic here isn't in the answers. It's in the questions themselves and how they build this entire world of understanding for a little kid. The thinking behind this thing is, well, it's just so clever. Just to give you a little taste, check this out. For a computer, the question is, my food is, and the answer is electricity. Now think about that. That's not just a fact, right? It's a metaphor. It immediately makes the machine feel like a living thing. It gives it a need, a kind of sustenance, just like us. And that is exactly the kind of brilliant, simple analogy we're going to be digging into. All right, so here's the plan. First, we're going to see how the test splits the world into man-made and natural. Then we'll look at how it gives the computer body parts and even figure out what it eats. And stick around, because the last part is the real genius move. A lesson on computer logic that somehow involves making juice. Yep, juice. So where do you even start? Well, before this test even tries to define what a computer is, it does something more fundamental. It has to put it in the right box, you know? So it starts by splitting the entire world into two very simple categories.
See, on one side, you've got your natural things, mountains, trees, animals, all that stuff. And on the other side, you've got man-made things, calculators, computers. This is the very first, absolutely crucial distinction it makes. A computer isn't something that just grows. It's something that people build.
But wait, it goes one step further. It doesn't just say machines are man-made and leave it at that. No, it defines them as things that make our work easy. And that's huge. Right from the get-go, technology is framed as this helpful thing, a tool built with a purpose, specifically to help us. Okay, so we've established a computer is a helpful man-made machine. Great, but what is it? How do you explain all the bits and pieces inside? To make all that abstract hardware feel real, the test does something amazing. It compares a computer's parts to the one thing a 6-year-old knows better than anything, their own body. And naturally, it starts with the most important part. The test just comes right out and asks, which is the computer's brain? Think about that. That one simple question completely transforms this mysterious box of wires and circuits into something you can actually relate to. It suggests there's a center of thought, a place where the control happens. And the answer, as you probably guessed, is the CPU. The test just puts it out there, plain and simple. It is known as the brain of the computer. You know, this single metaphor is probably the most successful and longest-lasting analogy in all of tech education. And for a really good reason. It just clicks. You get it instantly. So once you have the brain, you can start building out the rest of the body, piece by piece. The monitor, that's kind of like the face, right? It shows the work you have done. The keyboard and the mouse become the hands, which you use for typing and to move the pointer. You see the pattern here? Every single part gets a simple, active job. It's defined by what it does. All right, we have a body. So what's next to make something feel alive? Well, it needs energy, and it helps if it has some superpowers. The test just keeps going with this personification idea to explain the whole concept of power, and it cleverly contrasts the computer's strengths with our own human limits. So the test starts laying out these superpowers. We already know its food is electricity, but here's another one. Unlike you and me, it does not get tired. It has memory and can remember things. But, and this is a big but, it also has a key weakness. It's not independent. It needs commands to do work. So yeah, it's powerful. But at the end of the day, it's still our tool.
And this brings us to what I think is the absolute heart of the whole lesson. How in the world do you explain the fundamental process of all computing, that whole input, process, output thing, to a little kid? Well, you don't use a bunch of abstract terms. You use an analogy that is so perfect, so simple, it's just genius. You use a juicer.
Okay, check this out. Here's how it works. Step 1, you put fruit into the juicer. That's your input. Step 2, the juicer, which is a machine, does its work. That's the process. And step 3, the machine gives you something totally new, the juice. And that's your output. It's a perfect physical model for a completely digital process. It's brilliant. And because you have this really tangible analogy, it suddenly becomes super easy to define the abstract stuff. Input, that's just what you give to the computer. It's the fruit. So in the test, that's things like the keyboard and the mouse, or even just the data you're typing in, like 2 plus 2. And output, well, that's the result the computer gives back to you. It's the juice. In computer speak, that's what you see on the monitor or what comes out of the printer. It's the answer to your sum 4. And just like that, the entire logical loop is closed, all thanks to a simple, everyday example. So what's the big takeaway from all of this? It's that our entire foundation of technological knowledge, it isn't really built on code or circuits, is it? It's built on these simple, human-centric metaphors. We learn about something new by comparing it to something we already understand. You know, the brain, the food, the body parts, the juice, these aren't just cute little terms to help kids pass a test. They are the absolute fundamental building blocks of technological literacy. They create this intuitive mental model that honestly stays with us forever, shaping how we see and use every single device we touch for the rest of our lives.
And all of this leaves me with one last thought. The juicer was the perfect analogy for teaching basic computing. But as technology gets exponentially more complicated, what are the new juicers? What are the simple, powerful metaphors we're going to need to explain things like neural networks or quantum computing or AI to the next generation? What will their first computer lesson even look like?